All right, next section, 5.3, inverse functions. We're going to talk about just kind of some basic stuff with inverse functions. We're not really going to get into some derivatives or something like that. Some just basic stuff here. So a function g is the inverse function of the function f if f of g of x is equal to x and g of f of x is equal to x. So if I put f into g or if I plug g into f, and if it equal x on both of them, then they are technically inverse functions. If g is the inverse of f, then f is the inverse of g. Okay, so they go back and forth, and then it's just notated by f to the negative 1, right? It's not f to the negative 1 power, it's f to the negative 1 as the inverse, right? It's the inverse of f. So a function does not have to have an inverse function, but if it does, the inverse function is unique. So there's no other function that's going to have the same inverse function. If the function has an inverse, then the inverse can be found by switching the x and y variables and solving for y. So that's, hopefully, remember that from pre-calculus. If not, well, oops. So find the inverse function and verify they are using composition. So if I want to say this is really y is equal to 2x to the third minus 1, finding the inverse, we flip the x and the y's, so 2y to the third minus 1. So this is really x plus 1 divided by 2 is equal to y to the 3. And then therefore I get y equals the third root of x plus 1 over 2. Okay? And so in order to find out if this is the right inverse, we're going to say, okay, this is f inverse, okay, of x is equal to this function here. And so I'm going to say f of f inverse of x is equal to 2 times the third root of x plus 1 squared to the third power minus 1. Well, this is if I cube a cube root, I get x. I get the inside. 2's are going to cancel, so I get x plus 1 minus 1. So that's equal to x. So that works. If I take f inverse of f of x, I get the third root of 2x to the third minus 1 plus 1 over 2. That's the third root. So that is going to be, the plus 1 minus 1's are going to cancel, right? The 2's are going to cancel, so it's the third root of x to the third, which is x, so they are inverses by composition. Existence of an inverse function, so horizontal line test. Remember, we had a vertical line test to determine if the function has, or if the relation is a function, so it's vertical line. Horizontal line test is if you draw horizontal lines through the graph. If it only touches the graph once, then the function is going to have an inverse. So this one has an inverse. Pretty simple. Okay. If I draw a line through the function and it crosses more than once, 2 or more times, then this is not going to have an inverse. Not an inverse, or not going to have an inverse function. Okay. Fantastic. Pretty self-explanatory there. Some properties of a function and its inverse. If f is continuous on its domain, then the inverse is also continuous. O-U-O-S. Or U-O-U. Oh, I always spelled that wrong. U-O-U-S. U-O-U-S. Is on its domain as well. If f is increasing on its domain, then the inverse is also increasing on its domain. If f is decreasing, therefore f inverse is decreasing. If f is differentiable on an open interval containing c and there is a derivative of c such that it doesn't equal 0, then f inverse is also differentiable. Okay, at that point, as long as that point, the derivative is not 0. If f contains the point AB, then the inverse contains the point BA. Right, we got to flip the x's and y's. So the graphs of f and f1 are reflections about the line y equals x. So technically this line right there is y equals x, right? And so this point is a comma b. When I flip it, it's now b comma a. And I flip that line about that x axis. All right. I'm sorry, about that y equals x axis of symmetry. Sorry. Okay, that's it for this video. All right, I'll catch you in the next one. Deuces.